In this question from JEST 2024, we have a particle of mass small m. It is moving in a potential given. We have to identify the correct expression for energy of a bound state for beta greater than 0. Beta is dimensionless. Here we can use the condition for bound state in quantum mechanics. If E is less than V of R tending to plus or minus infinity, then the state is bound state. Then state is bound. The given potential, it is equal to 0 when it is tending to plus or minus infinity. Therefore, E must be less than 0 for bound state, which means option B and D cannot be correct. Now the correct option among A and C will be the one having the dimensions of energy. Let us find the dimensions of expression in option A, minus beta h cut raised to 6 alpha square m cube. Now beta is dimensionless. Dimensions of h cut is dimensions of h, which is equal to, let us write units instead of dimension, kilogram meter square per second square. This is units of energy times unit of time is second, which is equal to kilogram meter square per second. Now if you don't know how I wrote this, then you can start with E is equal to h nu. From here you can write dimensions of h is equal to dimensions of E divided by dimensions of nu, and from there you will get this, and when you finally write the units you will get this, kilogram meter square per second. Now someone can also forget the dimensions of or units of energy, then they can start with dimensions of energy is equal to dimensions of work, and work is force over displacement, and force is mass times acceleration. Now mass units is kilogram, acceleration units is meter per second square, and displacement units is meter. From there also they can get kilogram meter square per second square. This is the units of energy. Alright, so we have h cut dimensions equal to kilogram meter square per second. Therefore h cut raised to 6 dimension will be equal to kilogram raised to 6 times meter raised to 12 s raised to minus 6. Now we have to find the dimensions of alpha square. Let us first find the dimensions of alpha. Dimensions of alpha is equal to, alpha is related to V and Dirac delta in 3D. Let us use that. Dimensions of alpha is equal to dimensions of V divided by dimensions of Dirac delta in 3D. This is equal to, V has same dimensions as energy, therefore units will be kilogram meter square per second square divided by dimensions of Dirac delta in 3D is per meter cube. Where is it coming from? We have integral Dirac delta in 3D dV is equal to 1. This is dimensionless. This has dimensions meter cube. Therefore this must have dimensions meter raised to minus 3 to make it dimensionless in left hand side as well. Therefore dimensions of alpha square will be equal to, here it is kilogram meter raised to 5 s raised to minus 2. Dimensions of alpha square will be equal to kilogram square meter raised to 10 s raised to minus 4. Now dimensions of mass is kilogram, therefore dimensions of mass cube will be equal to kilogram cube. If you put all these things here in the dimensions of minus beta h cut raised to 6 divided by alpha square meter cube, then you will find that this dimension will be equal to kilogram meter square, or units will be equal to kilogram meter square per second square, which is same as the dimensions of energy. So option A is the correct answer because it is matching with the dimensions of energy.